In this question, we're being asked to add the mixed number 2 1/3 to the fraction 4/5, and we do this by changing the mixed number into a top-heavy fraction. So there's a little process for that. So you just multiply the 3 to the 2 and then add it to the 1. So 3 times 2 is 6, plus 1 is 7, and it becomes 7 over 3. So you just need to remember how to do that, just that little process. And then we're just going to leave the fraction for the time being, so plus 4 over 5. So now we've changed it into adding two fractions. To add two fractions, they've got to have a common denominator. So we're going to multiply these denominators together to make the common denominator. So 3 times 5 is 15. So both fractions are going to become over 15. And then we're going to cross multiply to get the numerators. So the 3 is going to multiply up to the 4 to give us a 12 on the second fraction. And then the 5 multiplies up to the 7 to give us a 35. The other way to think about that is that we've just multiplied this fraction top and bottom by 5 to get 35 over 15, and we've multiplied this one top and bottom by 3 to get 12 over 15. So just multiplying the opposite fraction top and bottom by the denominator. Or thinking of it as multiplying those and then cross multiplying. So a couple of different ways to think about that, but either way you would get the same result. Now we can just merge these, so 35 plus 12 is 47 over 15. So you might leave it like that, or you might want to put this back in terms of a mixed number. You probably want to put it back as a mixed number. So we achieve that by just thinking, well, how many 15s go into 45? So 2 15s is 30, 3 15s is 45. Sorry, how many 15s go into 47? So 3 of them make 45, so it'll be 3 sort of whole numbers, and we're left with 2, because 3 times 15 is 45, but we've got 47, so we're left over with 2. So it becomes 3 and then 2 15ths. And that's the final answer for that problem. In this question, we're being asked to expand these brackets and then simplify by collecting together the like terms. So in the first case, we've got two brackets multiplying. The second case is just a whole number multiplying into the bracket. So it should be a fairly straightforward question, this. So remember, when multiplying out the brackets, everything in the first bracket multiplies to everything in the second. So some people like to put on little arrows to indicate how that's going to work, something like this. So we've got 3x times x, which would give us a 3x squared term. Then 3x times minus 1, which would be minus 3x. And then we've got 1 times x to give us just a plus 1x, or just plus x. And then 1 times negative 1 to give us a negative 1. So you just got to be careful there with the plus and the minus, and watch out for missing things like double negatives. There weren't any double negatives in this particular question. 2 times x squared in the second bracket gives us 2x squared. And then 2 times minus 5 gives us minus 10. Okay, now it's just a case of collecting together all the like terms. So we've got 2x squared terms, so 3x squared in the first term, and then positive 2x squared, so adding those together to give us just 5x squared. And then collecting together your x terms, so we've got negative 3x plus 1x, so it's minus 3 plus 1, which is minus 2, not minus 4, so it's minus 2. A lot of people want to make that minus 4, so minus 2x. And then just finally collecting together the number terms, so minus 1 minus 10. So that's not a double negative, that's just minus 1, the number minus 1, take away another 10. So it's going 10 more negative, so that'll end up at minus 11. So quite straightforward questions, though. It's just got to be careful with the plus minus and the numeracy. In this question, we're being asked to solve this system of equations. So system of equations just means simultaneous equations. So we're just going to go through the standard method for solving these. So it's good practice, although not necessary, to label your equations, just to identify which is which. So we're starting off with equations 1 and 2. And remember, the key with these questions is to get the coefficients of either the x's or the y's to match up. And that's the variable, the letter that we're going to eliminate. This is called elimination of a variable. So to achieve that, we're going to multiply by the opposite number to get either the x's or the y's matched up. It doesn't matter which you choose, but choose probably, especially in a non-calculator question, the most easy numbers to do the numeracy with. So I think it will be these two. So I'm going to multiply this first equation by 2, and I'm going to multiply the other equation, this equation, by 5. So we're multiplying this one by 2 and multiplying this one by 5, just because this number here is 2, so we multiply the other equation by 2. and this one here is 5, so we multiply the other equation by 5. So that's going to give us two new equations, equation 3 and 4. So multiplying every term by 2, so the 4x becomes an 8x, the 5y becomes a 10y, the negative 3 becomes a negative 6, and that's going to be equation 3. And then multiplying the second equation by 5, so this becomes a 30x, this becomes a minus 10y, and this becomes a 25, and that becomes equation 4. So now that we've got these matched up, it doesn't matter if the plus or the minus is matched up. It could be both plus, it could be both negative, or one of each. But you've got to consider that when you eliminate these. So these don't just automatically eliminate. They only eliminate if you add or subtract the equations correctly. So we want this to go to 0, so I'm going to add my two equations this time. So we're basically doing equation 3 plus equation 4. And you can write that in if you wish. You can write something like equation 3 plus equation 4. Working in the column, so 8x plus 30x, so adding those together is going to give us 38x. When you add these together, 10y plus minus 10y, well that's just 10y minus 10y, that's 0. So they eliminate, and then just pulling down our equals, adding these together, so negative 6 plus 25, that's just 25 minus 6, and that's 19. Okay, so we've got it down to 38x equals 19. You can move this closer if you wish. Dividing both sides then by 38, so we're going to get 19 over 38. Very tempting to make that into 2. It's not going to be 2 though, because we're dividing the smaller number by the bigger number. It's actually going to be 1 over 2 instead of maybe what would intuitively, we want to make it a whole number, 2 over 1 or 2. So the answer is 1/2. Or you can call it 0.5 if you wish, it's up to you, either way is fine. And that is a thing to consider because we now need to substitute this back into one of the equations to get the next solution, the y solution. Sometimes it might be easier to use the fractions, sometimes the decimal, and this is where you've got to make a smart choice about which equation to use. Certainly use equations 1 or 2. You don't want to use the ones that you've multiplied up because if you use those, the numbers are going to be bigger. So going back to equation 1 and 2, remember you're putting x into the equation, choosing one of these versions of x, 1/2 or 0.5. These are both even numbers, so it doesn't massively matter which one you choose, but if one had been an even and one had been an odd number, you might want to go for the even number. I'm just going to go with, I think, the first equation. So what we're doing here, we're going to say that we're going to substitute x equal to 1/2, and we're going to substitute that, in my case, into equation 1. But it doesn't matter which of the 4 equations you use, you'll still get the same answer for y. So I'm going in here, so keeping the 4, replacing the x with 1/2 or 0.5, I'm going to use 1/2, so 4 times 1/2, using a bracket for that, plus 5y, just keeping the rest of the equation the same, equals negative 3. And this is just a linear equation now for us to solve, a normal equation to solve. 4 times 1/2, that's 1/2 of 4, is 2. So this is going to become 2 plus 5y equals not negative 6, negative 3. Let me just quickly correct that, if that'll let me rub that out. So negative 3. And then we're just going to solve this like a normal linear equation. So moving the 2 to the other side, that would become a minus 2. So minus 3 minus 2 is minus 5. I think that's what I was trying to do there. And then y is then minus 5 divided by 5, which is negative 1. So very, very procedural, those simultaneous equation questions. Definitely one where you're looking to get all the marks. In this question, we'd be given these two vectors u and then the resultant vector u plus v in component form, and we're asked to find the vector v. So the way this works is almost a little bit like algebra. These are obviously vectors, but if you've got u plus v, like this, and then you subtract from that u, then that will give you v. So that's what we're going to do. We're going to take our u plus v, which is this guy here, the vector 6, negative 4, 3. We're going to subtract from that the vector u, which is 1, 5, 1. And that's going to give us the vector v. So I'm going to put my v over here actually. So v equals that. So v equals u plus v, this guy, minus u, this guy, and that's what we've got set up here. These are in component form, so we can just go ahead and subtract the corresponding components. That's how it works. with component form. So 6 minus 1 is 5, minus 4 minus 5 is minus 9. Just be careful with the numeracy. 3 minus 1 is 2, so that is the vector v. And you could check that by taking u, this vector u and v, and adding them together, and you should get u plus v. So 1 plus 5 gives you 6, 5 minus 9 gives you minus 4, and 1 plus 2 gives you 3. So those questions are usually the other way around, like working out u plus v, given u and v. This one goes the other way, but it works just almost like simplifying algebraic terms, even though these are vectors. So that is the final solution for that question. In this question, we've been given this quadratic equation and we're asked just to solve it. So not a lot of information to go on, which means you've got to think about how do I solve a quadratic equation? Well, there's two methods. There's only two methods. You can either solve it by factorizing, or you can use a numerical method, the quadratic formula. If it's a quadratic formula question, well, two things about that. One, it means that this wouldn't factorize probably, although you can always use the quadratic formula. But if it does factorize, you don't want to use the quadratic formula because it's a lot longer and just more time consuming and more chance of making a mistake. And secondly, if it was quadratic formula, they'll mention in the question decimal places. There's no mention of decimal places here. That implies that it's going to be a factorizing question. And also the fact it's in the non-calculator paper. The ones where you've got to use the quadratic formula are usually in the calculator paper. So we are hoping that this will factorize, and we'll soon find out if it does. It's a trinomial, so we'll factorize into two brackets if it does factorize. So we need an x and an x, and then we need two numbers that multiply to make 24 and combine to make negative 11. So thinking about the factors of 24, so it could be 24 and a 1, it could be a 12 and a 2, it could be a 6 and a 4, or it could be an 8 and a 3. Those are the possible combinations. We're looking for the combination that can make an 11. So you don't even need to worry about the signs, the plus or minus at this point. It's just, can these numbers combine in any way to make an 11? The only one is this one. An 8 and a 3 can be used to make an 11. None of the others could make an 11, so it has to be an 8 and a 3. Doesn't matter where you put the 8 and the 3, I'm just going to put them like that. Now we need to think about the fact that it's a plus 24. If these are multiplying to make a positive 24, they could either both be positive or both be negative, because two negatives still multiply to make a positive. But to decide whether it's plus plus or minus minus, we then look at the 11, and it's not just an 11, it's a minus 11. So that tells us it has to be minus and minus. So minus 8 multiplied to minus 3 gives you plus 24, and minus 8 minus 3 gives you negative 11. So we're just going to separate these into two linear equations. So x minus 8 equals 0, x minus 3 equals 0, and then just solving these to get x equals 8 and x equals 3. So those are the two solutions for that quadratic equation. In this question, we've been given a graph of a transformed cosine graph. In other words, not a normal cosine graph, one that's had something done to it. And we're told that the equation of this graph is y equals a cos bx. And we've got to figure out the a and the b values. And it's just a state question, just to write down your answer question, no working required. So the way we need to do this, we need to compare this graph to a normal cosine graph. Normal cosine graph looks like roughly like this. I mean, the shape is pretty similar. The end point is normally 360 degrees. That's how far you have to go to get one cycle. And the highest point, the maximum value is 1. The lowest point, the minimum value is normally minus 1. So basically we're playing a game of sort of spot the difference. What is the difference between that and that? Well, the first thing is that instead of having this range of 1 to minus 1, it's going from 5 to minus 5. So this normal cosine graph, y equals cos x, has been stretched by a factor of 5. So which of these relate to that stretch? Well, it's the amplitude value, the a value. So that tells us that the a value is 5. And you just need to know that that position of the letter makes that change to the graph. It stretches it vertically. The second change is that one cycle normally takes 360 degrees, but here we've got one cycle to 90 degrees and we've got a second cycle to 180. So this b value, the position of that letter, which is a number in reality, tells you how many cycles of the graph you get, but not just how many you can see on the diagram. So here we can see 1 2, but how many would appear between 0 and 360? So if you carried this graph on to 360, you would get another 2. So there's actually going to be 4 cycles in the range 0 to 360 when there's normally just 1. So that tells you that the b value, the number of cycles, is 4. So there's no real magic to that question. You've just got to know what the position of these letters mean, and you've got to know what the normal sine and cosine graphs look like so that you can basically spot the difference to the transformed graphs. In this question, we've been given this straight line graph, but rather than being a normal x, y axis, it's d and p. So this question's got a bit of context, a story. It's to do with the cost of a taxi journey. And the d, the horizontal axis, represents the distance. And the p, the vertical axis, is the cost, the price in p, pounds. So we've been given these 2 points, A and B, and we're not told what those points are explicitly. We're told in the, well, not on the diagram anyway, we're told in the wording in the question. So essentially the first part of this question, part A, is just a straight line question. So to make the equation of a straight line, which is what they're asking us to do here, using D and P, not the usual X and Y, we're just going to go through the normal process of a straight line, which is to find the gradient first of all and then make that into the equation. To find the gradient, we need 2 points on the line. So we've got points A and B, we just don't actually have their coordinates. So you need to look at the question for information. So I've got the diagram over here, and it says that point A represents a journey of 8 miles and cost £14. So that's basically just the point 814. So they're saying that if you go along 8, so the distance here is in miles, so 1, 2, 3, 4, 5, 6, 7, 8, the cost that would incur is 14, so that the height there would be 14. That basically just means that the point A is at 814, and that's often how these questions go. Point B, they're telling us, is 12 miles and 20 pounds, so that's just 12 and 20. So that's the first part to unlock this question, converting the information into actual coordinates. So 12 along and 20 up for that one. So we're going to make our gradient. So the gradient, remember, just using the gradient formula, is y2 minus y1, or the vertical change between the 2 points. So that would be the height between the 2 points, divided by x2 minus x1, which is the horizontal change between the 2 points. So good practice to label these up. So I'm going to call this x1, y1, and then x2, y2. Doesn't matter which way around you do that, you can call this x2 and y2 if you wish. Either way is fine. You'll get the same answer either way. And now we're just going to carefully put those numbers into the formula and see what we get. So this line clearly is sloping up to the right, so it should come out to be a positive gradient. So it's good to predict that in your mind before you do these. So just putting in the numbers, so y2 is 20 minus y1 is 14. And we're going to divide that by x2, which is 12, minus x1, which is 8. And just carefully processing the number, so 6 on the numerator, 12 minus 8 is 4. You could simplify this further, so that will become 3 over 2, and even use a decimal number if you wish. So 1.5. 3 over 2 or 1.5 would be fine. So we're trying to make the equation. So normal straight line equations are in the form y equals mx plus c. We're going to have to change the x and the y to d and p later on, but it's fine to work it in terms of x and y and change it at the end. So we now know the m value is 1.5, so y equals 1.5x plus c. And remember, when you're making a straight line, all you're really trying to do is to get the gradient, the m value, and the c value. So we're trying to find the c value now. That's the second step. To find the c value, just take one of your points, doesn't matter which one. I'm going to go for maybe this one, and this is going to be our x value, and this is going to be our y. So there's a lot of labeling of points in these questions, but it's a very standard process. So the y is 14, that's going to go here. Keep the 1.5. Remember, 1.5x means 1.5 times x, so that's going to be multiplying to the x value, which is 8, and then plus c. So this is a non-calculator question, so just be careful with your numeracy here. So 1.5 times 8, that's 1 times 8 plus 0.5 times 8. 0.5 times 8 is 4. 8 plus 4 is 12, so that comes to be 12 plus c. And then if we solve that equation, we would get that c equals 14 minus 12, which is 2. And if you look at the diagram, remembering that the c value is the y-intercept, that could be at 2, couldn't it? It could be like 1, 2. So it looks to fit in with the diagram. So our equation there then is y equals 1.5x plus 2. We need to write it in terms of d and p. So p is playing the role of what would normally be our y value. So that is where the p goes, and the d is playing the role of what is normally the x. So that is 1.5d plus 2. So that there is the equation of the line. That is part A of the question. And remember that what this formula does for you, yeah, it's a formula for the straight line, but it's also the formula that connects the distance and the price, the distance and the cost. That means that if you know a distance, you can turn it into a cost. And if you knew the cost, you could turn it more complicated that way, but you could turn that into the distance. In part B of the question, we're told that the distance is going to be 5 miles, and we want to work out the cost of that 5-mile journey. So that means that we're just substituting a 5 into here. So we're just taking our formula, which is P equals 1.5D plus 2. We're just substituting in 5 for the next to the 1.5, so 1.5 times 5 plus 2. So this is non-calculator again, so we need to be careful with the numeracy. So 1.5 times 5 is 7.5. 7.5 plus 2, so that comes out to be 9.5. Now remember that it's a price, it's a cost, it's in pounds. So you would say, finally, that the cost is equal to £9.58. And if you think about it, so point A here was at 8.14, so that was 8 along and 14 up. We're trying to figure out how much the cost is for a journey of 5. So this here was 8, this here would be 5 roughly here. If you go up there and then along here, then we're going to land up somewhere there. And this point here, the one that was at 8 along the way, was at 14 up the way. So if that's 14, could that be 9.5? Yeah, it looks to be in the right place. You don't need to do that. I'm just showing you that to help validate that that seems to be an answer that makes sense. So typical straight line question, but set in the context of a little story, makes it a little more complicated, but it is essentially just the same process as a normal straight up straight line question. In this question, we've been given this quadratic function and we're asked to determine the nature of the roots. So that really is just a fancy way of saying how many roots are there, and the only possibilities are no real roots, 1 real root, or 2 real roots. To determine that for this quadratic function, we're going to use a discriminant. The discriminant is part of the quadratic equation, or quadratic formula I should say, and it's not the whole thing though, it's just the b squared minus 4ac. That's how we determine the nature of the roots. So we need the a, b and the c values. Remember, they're just the coefficients of these terms, and always start these questions by identifying those. It's good to explicitly write them down. So the a value here, the number that goes in front of the x squared term, is a 2. The b value is a 4, and the c value is a 5. All of these are positive numbers in this case, but often one of them is a negative, so you've got to watch out for double negatives. Generally in these questions, but not for this particular one. So we're just going to go ahead now and figure out what this comes out to be based on these numbers. So we've got b squared, which is 4 squared. So you can write that in as 4 squared, or go straight to 16 if you wish, minus 4 times the a value, which is 2. I'm just going to use a bracket to imply multiplication there. So this is 4 times a times c. So 4 times a using a bracket times c, also using a bracket of 5 like this, and then just basically processing, computing the number, and we're going to get 16 here. 4 times 2 is 8, times 5 is 40, and just carry on all the way until you get a whole number. So here we've got 16 minus 40, so it's negative 24. And the number itself, remember, doesn't matter, only whether it's positive, negative, or 0. In this case, it's come out to be negative. Negative is the scenario for no real roots. So you would say some kind of little statement to tie it all together. So since b squared minus 4ac is negative, so less than 0, the function has no real roots. And remember, you've got to get the word real in there, as opposed to something called complex roots, which it might have, but they're not part of this course, so we only care about the real roots. So that is a solution for this question. In this question, we've been given a rather complicated looking diagram, which I've not attempted to replicate. I've just drawn the triangle here, and we're asked to find the shaded angle, which is this one at point J, so the angle KJL. And generally in these properties of shapes questions, we find angles, especially angles inside triangles, not by finding them directly, but by finding the other two angles and then subtracting those two from 180, because all the angles in a triangle add up to 180. So thinking about the problem that way, knowing that we're trying to find this angle here, it really transfers the problem from trying to find this angle to really trying to find the other two angles. Now this one we've already been given, so that further helps refine what it is we're actually trying to find, which is really this angle here. If we can find this angle here, the one at point K, then we can just take these two away from 180 and that will give us the angle that we're interested in. Now obviously there must be some other way of getting to this, information, so we need to think about the bigger diagram. So if I extend this line here, so there's a line coming back here, and then there's a line going up this way, up to the center point, and there's a triangle basically built something like this. Excuse my diagram, by the way, it's not probably going to be exactly perfect, but just to put a kind of sketch up. So it goes roughly like this, and then there's more triangles going all the way around. And the shape is built into sort of 10 triangles. So that tells us that the angle at the center, so around the circle in the center, obviously is 360 degrees, but if it's split into 10 parts, then each of those 10 parts, each of those corners of the individual triangles is going to have an angle of 360 divided by how many there are. So it's 360 divided by 10. So each of those angles is 36 degrees. So that tells us that the angle in here, if we need it, I'm not sure if we do, is 36 degrees, and the angle in here, and indeed in all of the triangles, is 36 degrees. But these two other angles you can figure out from the diagram, maybe not on my diagram, but on the actual diagram you can tell that those angles are all the same. So that means that that angle and that angle are the same, and these guys are the same. Now if we think back to the angle we're trying to find, we could find this angle if we knew this angle and this angle, because we could subtract these two from 180 because it's a straight line to get this angle. So really we've kind of changed the problem from finding this guy to finding this guy to finding these guys and then putting it all together. And that's the challenge with these questions, is putting it all together. So if we focus on this triangle here, because the angles are all the same, so it doesn't matter which triangle you use, if we focus on this one here, then that's going to tell us that the angle here is going to be given by 180, so the angles obviously in a triangle add up to 180, and if we just call this, let's just give this a name, like a letter, like x or something like that. So if these angles are both x, remember they're the same angle, then it's going to be 180 minus the 36, so we're taking away the 36 that we already know. That would leave us both of these angles added together, but because they're the same angle, we just then need to divide that by 2. And that's going to give us each of the individual angles x and x. So 180 minus 36, that is 144, and we're going to be dividing that by 2, which gives us 72 degrees. And that looks reasonable, doesn't it, on the diagram? So that means that we now know that this angle here is 72 degrees, and this angle here is also 72 degrees. That means that we can now find the angle here, which we could label. So that would be the angle JKL. So JKL is 180 minus 72 minus 72. Because this guy's 72, this guy's 72, and this is whatever's left over from 180. So that's 180 minus 144, which is 36. So that angle in there is also 36. So that angle there and that angle there are obviously the same, but we need to go via the 72 to get those. So how does that help us? Well, now we can go back to our original triangle and we can find the angle we were originally interested in. I'll put it up here. So that was the angle K to J to L. So K to J to L, so this one here. And we're going to get that one by doing a similar calculation. It's 180 minus this one, 36, and minus this one. So minus 36 minus 17. So that's 180 minus, just quickly checking these, so that's going to be 40, that's 53. So the final answer is 127 degrees. Just by doing remember this is a non-calc question, so you just got to do those numeracy carefully. Now checking the answer here, checking the angle here, it's clearly bigger than a right angle, so it's into the probably hundreds. It looks reasonably like it could be 127 degrees, so it's always worth just making that quick check. If you get this angle to come out and you're working as 50 degrees, and clearly that's wrong, so just be careful that it does match up with the diagram. Properties of shape questions are never easy. There's a lot of piecing together, sometimes working backwards, but that's the kind of thinking you need for these. So that is the answer, 127 degrees for this problem. In this question, we've been given this non-right angle triangle XYZ, and we're asked to find the length of the top side, x to y. So these questions can either be Pythagoras or they can be sine or cosine rule. Because it's a non-right angle triangle, we've not been told it's right angled, we can knock out the Pythagoras and it has to be sine or cosine. So then we have to decide, is it going to be the sine or the cosine rule? Normally these are calculator questions and we would not be given information like this. But because we've been given this strange piece of information, that is a hint, a big hint, that it's going to be the cosine rule. So we're going to work this one up using the cosine rule. So that's already a bit of work, isn't it, to try and determine like what rule you're going to use, but it's just logical. It's not a right angle triangle, so it has to be sine or cosine. They're giving you a cosine piece of information, so it kind of suggests that it has to be cosine. So we want to use the cosine rule for finding the side length, which is, remember the cosine rule comes in two flavors. We want the side length version, which looks like this. This is just directly how it is written on the formula sheet. So a squared assumes you've got an ABC triangle, so a squared equals b squared plus c squared minus 2bc cos a. The important thing here is that these two have to match up, so they have to be referring to the same letter, one lowercase and one uppercase. So I'm just going to go ahead and fully label up my diagram. So this would be lowercase y over here, lowercase x and lowercase z. Now we're trying to find x to y, but x to y in our diagram is little z. So we want to therefore adjust our formula to fit in with the diagram, or you could adjust your diagram to fit in with the formula, but you've got to somehow put the right numbers in the right place. So I'm going to do it by changing the formula. So this is going to become a z squared, and then the other two letters don't really matter on the order. We'll just do it in alphabetical order. So x squared plus y squared, and whatever two letters go here have to also go here. So it's going to be 2 times x, so I'm making a mess on my board, 2 times x times y times the cosine of whatever goes there, so it's going to be the cosine of z. Now fortunately that cos z is a piece of information we've been given, because generally these questions are calculator and they don't give you this, they just give you this. So you don't get all of cos z, you just get angle z, which will be the angle here. There's no angles in this question. That's why they've given us all of cos z, to allow us to do this non-calculator. So we're just going to go ahead and put in the information. So x is 8, so that's going to become 8 squared. Y is 10, so that's 10 squared. You just got to go through the numeracy carefully. So 2 times 8 times 10 times the cosine of z, which is not the cosine of 1 over 8, which is what a lot of students want to write in a question like this. It's just 1 over 8. Can't be the cosine of anything, because that would need a calculator to then work that out. It's a non-calculator question. So we're just going to take this forward. So 8 squared is 64, 10 squared is 100. And just being careful with your numeracy here. Now here we've got 4 numbers multiplying together, but the order in which you multiply doesn't matter. So do it smart. Don't just do it necessarily in order. For example, 8 times 1/8, well 8 times 1/8 is 8 divided by 8. So these multiply together just to give you a 1. So that basically knocks out those terms and just effectively leaves you with the 2 times 10. I'll just take a line to write that in. So they basically cancel effectively. These two add together to be 164. 2 times 10 is 20 obviously, so like this. They subtract to give you 144. And remember at this point this is still z squared. So 144 would obviously be way too big for the diagram, but we still need the square root. So our z is equal to the square root of 144. This is a non-calculator question, but hopefully you recognize that number. It is a square number. Square root of 144 is 12. So So the final answer, which fits in quite nicely with the diagram, is 12. The units are centimetres, so Z is 12 centimetres. They had actually asked for XY, so you could maybe just write it as XY equals 12 centimetres. And that's the final answer for that one. It's quite unusual to get a sine or cosine rule which is non-calculator, but they will occasionally do it, and they need to give you something like this, cos Z equals 1 over 8, to allow you to answer that question. In this question, we're being told that the cosine of 60 degrees is 0.5, and somehow from that we've got to work out the cosine of 240 degrees. It's a state question, but it doesn't mean state in the sense of you should just know the cosine of 240, but it is state in the sense of there's minimal working that needs to be shown. But somehow we need to get from this to the cosine of 240. There's a couple of different ways you can do it, either using the graph of the cosine function, which is what I'm going to demonstrate, or you could use a CAST diagram. Personally, I think the graph would work better. So if you're ever trying to use a graph to get values, you've got to draw a reasonably accurate graph. The more accurate it can be, the better. Or to put it another way, if you make a terrible graph, then it's actually going to throw you off. It's not going to help to get the correct answer. So the cosine graph goes something roughly like that. And we've got these key points. So this key point here is at 90 degrees. This key point here is at 270 degrees. And then there's some others as well, but we'll just leave it maybe at those two. So what does this mean, cosine of 60 equals 0.5? Well, it means that if you go along the way to 60, which would be maybe like roughly there, so that's 60 degrees. If you go up from there to the graph, so that will hit the graph like there, and then go back to the y-axis like that, then that tells you that that is 0.5. Remember the vertical labels are, so 0 here and 1 here is the maximum value is 1. So that's telling you if you go along to 60 and go up like that, it would give you take you to 0.5. So that's all that information means. Somehow we've got to use that to figure out the cosine of 240. So 240 is like here somewhere. But notice that that gap we've left in here is 30. So that was 60 and that's 90. So it's a gap of 30. And if we're now working with 240, which is here, sorry, the diagram's getting a bit messy already, then that's also a gap of 30, because that next point, that key point, is 270. So there's a bit of symmetry going on there, and this question's all about the symmetry. So if we then take the 240 down to the graph, and then go back that way, by the symmetry, that should be in the same position down the way as that one was up the way. This lowest value is -1, so this one here, the one that we're interested in, is right in the middle, so it's minus 0.5. So it's really about using the symmetry of the graph, this question. So that tells us then that the cosine of 240 degrees is like the cosine of 60 degrees, but down the way instead, so it's minus 0.5. So tricky little unusual question, that one, only a 1 marker, not really a very standard question type. In this question, we've been given a diagram which shows an X, Y, Z axis, and we've been given these 2 points A and E, and we've got to somehow piece it all together and figure out the coordinates of points B and C. So I've not drawn the diagram, I'm just going to refer to the diagram that I've got on a screen over here. So these are 3D coordinate questions. They tend to be quite poorly done. You've just got to be really, really careful with your interpretation of the diagram. And one of the big mistakes that I see is, and it's understandable, so remember when you're drawing an X, Y, Z axis, the X goes that way, which is the normal X direction, but the Y goes back the way. So the Y is going into the board. It's going on a dimension that we can't actually see. Like I'm drawing this on a 2-dimensional screen, a 2-dimensional board, but we're trying to imagine a 3rd dimension. That's what tends to cause a problem. So X that way, Y back the way, and then Z up the way. So just be mindful of that. So a lot of people still think of it as X and then Y and then Z going back the way. So somehow we've got to use the points we've been given to figure out the points we're interested in. So let's maybe start with point B. So point B is at the very back of the shape and it's at the very top. So that's going to be really important information. So point B, and then we're going to try and figure out point C. So just take the coordinates one at a time. So if you look at point B, it's right at the very, well, we'll start with the X coordinate. So it's right in the very middle of the shape going along the X axis. So you can see that point E has got an X coordinate of 2 and point A has got an x-coordinate of 4. Now point B lines up with the x-coordinate of A, doesn't it? They've got the same x-coordinate. They're both the same length along the x-axis. So these questions are all about copying other coordinates. So point B's got the same x-coordinate as point A. So we can just write in the x-coordinate as 4. Point B's y-coordinate, remember, is the one that goes back into the board, in my case, or into the paper, or into the screen. It's at the very back of the shape. Now, there's no other point given at the back of the shape, but we're told that the shape has got a length, like in the y direction of 8. So that tells you that point B lies 8 back the way along the y-axis. So basically the y-coordinate of point B is 8. And point B lies at the very top of the shape and the same height as point A. So the z-coordinate, which is the up and down measure, the vertical measure, is also 5. Okay, so not easy, just try to piece that all together. And then the other point we're trying to get is point C. So point C is at the very end of the shape going along the x-axis. So point A is at 4, point E is at 2. That tells you that the shape between the end point E and the middle point is a gap of 2. So the other end would be a gap of another 2. So it goes to 2, to 4, and then point C, which is at the extreme other end, would be at 6. Like that. This bracket's in the wrong place, so it should be like there. And then thinking about the y-coordinate of point C, well, it lies at the very back of the shape in the y direction, the same position as point B. So we can copy point B's y-coordinate, or use the fact that the length of the shape is 8. It's at the back of the shape, so it's got to be 8 units back the way. And point C lies at the very bottom of the shape in terms of the vertical height. So it doesn't have any vertical height, so it's going to be 0. So they're not easy little questions. They tend to not be very popular, but that's the way you need to think about those ones. So those are the two coordinates we're looking for, B and C. In this question, we've been given this formula and we're asked to change the subject to x. So remember, that just means like rejumbling the formula to put the x on its own and all the other letters on the other side of the equation, other side of the equal. So at the moment, y is the subject of the formula. So we need a few algebraic moves to make x a subject. It's always good practice to get your variable that you're trying to make your subject letter on the left-hand side, but rather than subtracting that term over, just spin the equation around. So just write in what is on the right-hand side on the left and what is on the left-hand side on the right. So that makes a significant difference as well, because we generally prefer the subject letter to be on the left. So just writing that over here and then writing the y on the other side. So you wouldn't get any marks for that. That's not really one of the algebraic moves. It's just a good practice to do that, but it's not necessary. Not everyone does that, but most people do. Now, basically, it's a game of moving everything away from the x. When you're trying to make a subject of a formula, really it's a game of getting the things that are not the subject letter away from the subject letter on the other side of the equation. So I'm going to start by moving the h to the other side. So basically subtracting h from both sides. So we're going to get g times root x equals y minus h. And you can either think of that as subtracting h from both sides or just moving the h to the other side. But if you move something over the equals, it changes from a plus to a minus. Whichever way you think about that, that's how it would wind up. Now we're going to divide both sides by g to get the g on the other side. So we're left with root x here equals, remember the g needs to divide both the y and the h. So you could do those individually, but probably better just to make it over g like that. And then we're almost there, but we've now got root x. We need to get it all the way to x. So what cancels out a root is a squared. A squared cancels a square root. So effectively, we're just squaring both sides of the equation. When you square this, it cancels out the root to leave you just with an x. And we need to square the right-hand side. Best way to do that, only way to do that really, is just to put everything that you've got there, all of that, in a big bracket and just put a squared on the bracket. And so that is the final answer. That is x now being made the subject of that formula. So remember, these are the same formula, just written in a different way. We've just changed the subject, but still essentially the same formula. In this question, we've been given this rather unattractive looking expression and we're asked to remove the brackets and simplify. So it's quite odd wording in this question because it refers to brackets, plural, but there is only one bracket. So what do you think is going on there? Well, it's just that because it's squared, it's kind of secretly a second bracket. So there's two ways you can go about this question. You can either think of it as being two brackets, or you can just go straight to using indices rules. I'm going to show both methods. So if you do think of it as two brackets, then, because anything squared just means the thing multiplied to itself. So that would effectively just be the bracket twice. So it would be 2/3 p to the power of 4 multiplied by 2/3 p to the power of 4. And I guess that's maybe how they expect you to do it, given the wording of the question. When you come to do a calculation like this, the number terms multiply together and the algebraic terms multiply together. So maybe just to separate that out, I'll just show that. So it's going to be 2/3 multiplied to 2/3, and then that's going to multiply to p to the 4 multiplied to p to the power of 4. These will multiply just as normal fractions, so multiplying the two tops and the two bottoms, so we're going to get 4 over 9. These are going to multiply together using the indices rule, so this becomes p to the power of 4 plus 4, because when you multiply you add the powers, so this becomes p to the power of 8. And that's the final answer, thinking of it that way. So just to show the other way you could do it, so 2/3 p to the power of 4 squared. So you can just go straight to using indices rules, and the indices rules in this scenario say that if you've got a bracket like this, then you apply the power to each term individually. So that would be 2/3 squared, and then you get basically p to the power of 4 to the power of 2. But if you've got a power on a power, the indices rules say that a power on a power, you multiply the powers. So this is going straight to p to the power of 8. And when you think about a fraction like this, you can split the squared onto the numerator and the denominator like that. And then you can see that 2 squared is 4, 3 squared is 9, p to the 8. So you get the same answer either way. Either method, either approach would be fine. It doesn't specify any particular way in the question, but that is the final answer for that one. In this question, we've been given this quadratic function and we're asked to sketch the graph. Sketching a graph is not really about sketching the graph, it's about finding the key points to then allow you to sketch the graph. So we are not going to be going straight just to somehow magically sketching the graph of this. We need to build up the key points first, and then sketching the graph, which will be a parabola in this case, will be trivial once you've got the key points. So in the question they're telling us that we should, on our graph, have the x-intercept, the roots, the y-intercept, and the turning point. So that's really what the question is about, finding those points and then putting them onto the sketch. And if you find those points and they're all correct, it should give you a consistent sketch, one that actually works. If not, then it'll be some shape that doesn't work, doesn't look like what it should look like. So why, first of all, why have they given the formula like this? Well, if you multiplied out the brackets here, you would get like an x squared, and you would get a negative 6x, and you would get a plus 4x and a minus 24, and then you could combine that and it would all become a trinomial. So this is a quadratic function, but it's just been written in the factorized form. But if they write it in factorized form, or any other form, completed square form, or anything else, it's not because they're trying to make it more demanding, it's usually to help you. So why does this help us? Well, it helps us because the first thing we're going to try and find are the roots. The roots, remember, are just the x-intercepts, and the x-intercept is just, where the graph cuts over the x-axis. But to find the roots, the key with that technique is that we're going to let the y be 0. Because if you're a root point, if you're an x-intercept point, if you're on the x-axis and your vertical coordinate, your y-coordinate is 0. So we're putting a 0 into the formula. So we're going to sub 0 into the formula. So we're going to get a 0 here in the place of y. And this is where the factorized form helps us, because this is a quadratic equation to solve, but it's already been factorized for us. So we can go straight basically to the solutions. So we're going to get x minus 6 equals 0, and we're going to get x plus 4 equals 0. And if we go ahead and solve those, we're going to get x equals 6, and we're going to get x equals negative 4. So that tells us our root points are at 6, 0, and at negative 4, 0. So that's the first thing we're asked to find, is the roots. The second thing, or the next thing I'm going to do anyway, is the turning point. So the turning point, remember, by the symmetry of these parabola graphs, always lies right between the two roots. So between 6 and negative 4. So how do we actually find that? Well, just take the two numbers and add them together. So 6 plus minus 4, which is just 6 minus 4, and just divide by 2 to find essentially the midpoint, because the turning point always lies right between the roots. 6 minus 4 is 2, divided by 2 is 1. So that tells us the x-coordinate of the turning point is at 1. So the turning point is going to have a coordinate of 1, but we still need to find the y-coordinate. We're going to find the y-coordinate though, just in the same kind of way that we found these root points, by substituting into the equation. So we're substituting a value of 1 in, so this was for the x, remember. So x is 1, so we get 1 minus 6 in the first bracket, and then 1 plus 4 in the second bracket. And just go ahead and compute these. So 1 minus 6 is negative 5, 1 plus 4 is positive 5, negative 5 times positive 5 is negative 25. So that tells us the y-coordinate is negative 25. So not easy, quite a lot of working in this question. And then finally they're asking for the y-intercept. So the y-intercept, obviously just where the graph cuts over the y-axis, but we do the opposite of the roots. We let, for the y-intercept, we let the x equal 0. So again, we're just going to sub into the equation. It's all about subbing into the equation. So putting in 0 here for x, so we get 0 minus 6 times 0 plus 4. So very similar to this calculation down here. 0 minus 6 is negative 6, 0 plus 4 is 4, multiplying those together, and we get negative 24. So that then tells us that our y-intercept is at negative 24. Okay, so where are our key points? So these are our two root points here. This is our turning point, and this is our y-intercept. So it should be that when we come to draw a graph, all of these points sort of work. So a little tip, I mean, this is only a sketch, right? It doesn't have to be like super accurate, but a little tip for you, when you come to draw these sketches, notice that some of the numbers like minus 24, minus 25 are significantly bigger than the others. So start with the bigger ones, because if you start with the small ones, then the big ones are probably going to spill off the screen. So the biggest number here is the minus 25. So the point 1 minus 25, that's 1 along and 25 down the way. So let's just imagine that's like there somewhere. So sometimes you've got to imagine a different scale on one of the axes. So 1 along, 25 down the way, roughly like that. The next point I want to put on is the next biggest one, so 0 minus 24. That's the y-intercept, which is just a little bit above the 25. So that's going to be, you know, like here somewhere. And then we've got our two roots, so negative 4, 0. Negative 4, 0 would be somewhere there. And then finally we've got 6, 0, which is going to be a bit further along the way this way. So somewhere there. And then we're hoping that this all kind of fits together to make a reasonable parabola shape. Remember, this is your turning point, so it's going to go down through that point and turn and then go back up the way. So it looks pretty decent, right? They're all in roughly the right place. And you probably want to mark on the coordinates of these points. You definitely would actually on your diagram as well. Quite a lot of work in that question for only 3 marks, and really it's not like I say about the sketch, it's more about actually finding all the key points, but they've all got their own separate technique, which is why quadratics is a difficult topic. There's a lot of technique, a lot of things to remember. So that is the sketch for that quadratic function. In this question, we've been given a diagram of a square-based pyramid, which I've badly attempted to replicate here, and we're asked to find the height. So the height is a vertical height. It's not the height on like the side, it's the vertical height, so from the base all the way up to the top point. And we're told that the volume is 138 centimeters cubed. So generally volume questions ask you to work out the volume. This time they're giving you the volume and asking you to sort of work backwards to get the height. So there is a formula for volume on the formula sheet. So it's volume for a square-based pyramid. My one looks a bit rectangular, but it should be, let me just finish my diagram real quick. So it goes something like this, I guess. And so something like that. So you can see by the dimensions that it should be a square-based pyramid, and we're trying to find the height. So if you imagine like a point here, right in the very middle of the base, we're trying to find the height from basically from the top point down to there. So that's what we're after. Anyway, the formula is 1/3 times A times H. Can be a little bit confusing, that formula, because like, what is the A? Well, the A is the area of the base. Okay, so the area of this square base. So we're told, let me just quickly check actually, that the volume is 138. So 138 is going to go on the left-hand side here. So unusually, we're not just using the formula to work out volume, we've got the volume. So this is a working backwards sort of question. So the volume is 138. The 1/3 is just a constant, that stays there. The A is the area of the base. So the area of the base, which is going to be our A here, is literally just 6 times 6. So it's just 36 centimeters squared. Don't need the units in the formula, so it's just going to be 1/3 times 36. I'm just using a bracket to represent that multiplication. And the h we need to leave as h, because that's what we're trying to actually find here. So we're trying to solve this equation now. So just by picking out the correct formula, populating the information, you've probably already started to generate marks. And now it's just a case of using this equation to solve for the h. So one thing we could do is just to go ahead and process this number. 1/3 times 36 just means 1/3 of 36, or 36 divided by 3. So that just gives us 12 times h. And you can, if you wish, spin this around. So 12h equals 138. Non-calculator question, so you need to figure out a way to do this calculation. It's not a number that obviously divides by 12. So for example, 144 divides by 12. 138 doesn't divide perfectly by 12. So we're just going to have to work this out. Whichever way you think is best to do that, but I would recommend just starting by writing it as a fraction, because to get from 12h to h, we divide both sides by 12. These are both even numbers, so just start dividing them down by 2. Don't be too ambitious about dividing them by some bigger number. They'll quite quickly go to their final sort of destination. So if this had been 140, then 140 divided by 2 would be 70. So it's obviously just one unit of 2 less than 70. So basically it's going to be 69. Or you can just figure that out by some other way. So basically what I mean is 69 times 2 gives you 138, and dividing the bottom by 2 as well, we're going to get 6 like this. And again, these numbers don't exactly divide perfectly, but they do divide by 3. So dividing the denominator by 3, first of all, to get a 2. 3 goes into 20 times, and then we've got 9 left over, so that would be 23, like that. So 23 over 2, that would be okay as an answer. We might want to use a decimal number. So 23 divided by 2 is 11.5. So 11.5, and the units here were centimeters, so it's 11.5 centimeters. So quite an unusual volume question, that asking you to work it backwards. Normally volume questions go forwards, just asking you to work out the volume, and the numeracy in there is a little bit awkward as well. Just checking your diagram, does that make sense? If that's 6 there, could the height based on the diagram be 11.5? Oh yeah, it's in the correct ballpark. If that had been 115, then definitely not in the right ballpark. So always checking your diagrams to make sure that the answer is reasonable and kind of fits in. In this question, we've been given a slightly odd-looking trigonometric expression, and we're asked to write it in its simplest form. So this is an example of a trigonometric identities question. They're not very popular. They can be quite tricky. They always look a little bit different every time. They're only 2 or 3 mark questions, usually just 2 marks, so they're not the most important questions. To be able to unpack these, you need to know a couple of formulas, and these are not on the formula sheet. You just need to commit them to memory. So the one we're going to need in this question is that tan x is equal to sine x over cos x. So sine divided by cos basically gives you tan. Just need to know that one. And then secondly, if you take sine and square it, so sine squared x we call that, and you take cosine and square it, so cos squared x, and add those together, you get 1. So sine squared plus cos squared equals 1, and sine over cos equals tan. So there are like hundreds and hundreds of trigonometric identities. These are the 2 that you need to know for the Nat 5 course. So what you're doing, you're looking at your original expression and thinking, right, is there anything in these 2, and it can only ever be these 2, is there anything in there that fits? So there's no squares, is there, in our question, so we can rule this one out already, but this one fits. We've got a tan. So all we're going to do is replace the tan with sine over cos. So the sine and the cos in the original question, there's nothing we can do with those at this point, but we can replace our tan with sine over cos. I'm just going to use a bracket for that. So sine x over cos x. And even just by doing that, you've probably got a mark already just by pulling the formula from your memory into the expression. Now it's just a case of doing a bit of algebra. So here we've effectively got sine being divided by cos, but also multiplied by cos here. These are all multiplying together, and the order in which you multiply is up to you. So you can think of this in any sort of way. You could also pull these onto the top of your fraction. Let's maybe do it like that. So you could basically make this as like sine x, cos x, sine x, because if you multiply a fraction to something else, the other thing just goes on the top of the fraction. All of that divided by cos x. That's one way to think of it. There's multiple different ways to think about this. If you've got that scenario, then these would just cancel. They could just cancel from that line as well. It just depends how you see it. That's going to leave you with sine times sine. So you've got sine x times sine x, which is sine squared x. So it's either writing that as sine x in a bracket squared, or the common notation is like this one here, which would be sine with the squared in the middle, like that. The thing to not write is sine x squared, which is what instinctively you're going to want to write, but that actually means the sine of x squared, not sine x all squared, which is what we mean here. So either that form or that form would be acceptable. This form, not so much. Tricky little question, that one, but that is the solution for that problem. In the first part of this question, we're given this quadratic expression, and notice it is just an expression, it's not an equation, and we're asked to basically write it in the completed square form. So this is part A of the question and the first part, so part A, part 1. Just need to know how this process works. So the process works, it's an algebraic technique by taking half of the coefficient of the x term, so the number in front of the x, you half it, half of -6 is -3, making sure you keep the sign, so -3. Put a bracket, a squared on the bracket, and that's just always part of the process. Half the number, put the squared on the bracket. And there's a couple of different ways you can take it forward from here. Maybe the standard way is to then take the number you just put in the bracket and square it, -3 squared. That's -3 all squared, which is +9, but then you subtract that number from here. So it's -9 like this, and then -81. That's probably the standard technique. Then just combining the end numbers, so we get x minus 3 squared at -90. There's no magic to that technique, you just need to know how it works. It's very, very procedural. So half the number, put it in the bracket, put a squared on the bracket, the number you've just put in the bracket, square it, and then take it away, and then combine these numbers at the end. Okay, so the second part of this question is slightly different format in the sense that they've not just written it as an expression, they've written it this time as y equals. So y equals refers to the graph of that function. So we're thinking about the graph of this function. It's an x squared function, a quadratic, so it would make a parabolic graph. And we know that the parabola would go like this shape because it's a positive x squared term. And what does this tell you, this here? This tells you the turning point, doesn't it? This tells you the turning point is at positive 3 minus 90. And that's the interpretation we need for this part of the question. So the completed square form, the only point of doing completing the square is to get the turning point. So we now know that the turning point is going to be at 3, -90. So remember, when you're making the turning point from the completed square form, you change the sign on this one. So -3 becomes +3. This one stays the same. So 3 minus 90. It's a bit odd in this question having the -90. We normally don't see coordinates that are that big. But remember, these graphs carry on forever. So they can have like huge numbers. Okay, so anyway, that's a turning point. That's not what it's asking for though. It's asking for the equation of the line of symmetry, which would be the line that goes down through the turning point and cuts the graph, splits the graph in two. We want to get the equation of that line. It's a vertical line. Vertical lines have got their own format of equation, and it's just written as x equals. So it's not a y equals mx plus c type format, it's x equals. And it's just the x coordinate of any point on the line. The only point we've got is the turning point. It's got an x coordinate of 3, so the line of symmetry has got an equation, x equals 3. Okay, so a bit of piecing together in those two parts of the question. In the second part of the question, or part B of the question, they're taking the expression we had in part A, and we're being asked to set it equal to 0. And then we're being asked to show that the roots, in other words, the solutions to that equation, can be expressed in the form of the thing they've got there. So I'm just going to write that down for reference. So they're saying that this should come out to be that the solutions equal for x equal, let me just check that again, I've got it on the screen here. So it's quite a funny looking format. So d plus or minus d times root e. Okay, and then we're being asked to basically find the d and the e values, which just really means figuring out the roots, figuring out the solutions. So thinking about the roots of a quadratic equation and thinking about also why is there a weird plus minus here? So plus minus should be a big hint in this question. The only formula you ever see that in is a quadratic formula. So basically that's what we're trying to get to. You could actually solve this one using this form over here. And that's maybe not a terrible call. In fact, I might leave that as a challenge for you to think about how you could use that. So if you were to take this thing here equal to 0 and change it to that there equal to 0, you would be able to get to that solution fairly quickly. Instead, we're going to use the full quadratic formula. The full quadratic formula, by the way, is just based on the completed square form. Anyway, forgetting that, let's just think about the quadratic formula. So the quadratic formula says that your roots are equal to so that minus b plus or minus the square root of b squared minus 4ac, this is on the formula sheet of course, divided by 2a, where these values, the 1 here, there's a 1 in front, is your a, that's your b, and that's your c. So we can just start by nominating those. So we're going to say that our a value here is 1, that's the coefficient of the x squared term, the b value is -6, and the c value is -81, and we're just going to plug those into our formula. So x is equal to minus b, so it's minus minus 6, which is positive 6, plus or minus the square root b squared, so it's minus 6 squared, minus 6 all squared, which is 36, minus 4 times the a value, which is 1, times the c value, which is -81. So there's clearly going to be a little bit of numeracy in this question, and all of that is divided by 2 times a, 2 times 1, which is just 2. So let's just have a little think about this bit. I'll maybe do that as some side working. So we've got 36. Where should I put it? Let's put it up here. So we've got 36 minus 4 times 1 is just 4. So it's just 4 times minus 81. So that's going to be 36 plus, because it's going to be a double negative. So 4 times 80 is, that's like 4 times 8, like 32. So it's 320 plus another 4. So it's going to be 324. Okay. Adding those together, we get 360. So a nice sort of round number. So that's for this bit here. So we can now say that this is equal to 6 plus or minus the square root of 360 all over 2. This is the final question in the paper. The final questions tend to be quite challenging. So you can see this is quite a challenging problem. So now we need to think about how to get from this form here to this form here. It's not a million miles away. It's starting to take on some of the structure, but it's obviously not quite there. This needs to be simplified, right? Because here we've just got a root, but here we've got a number times a root. So we need to think about surds basically at this point. So square root of 360, turning this into a simplified surd, we could think of that as being root 36 times root 10. Okay, remember you just choose two numbers that multiply to make the 360 in this case. The square root of 36 is 6, so we get 6 root 10. And let's just check that and see if that would work. So if we go 6 plus or minus, changing this number to 6 root 10, does that sort of meet the criteria? Well, it does in a sense, because notice that they're saying this value and this value should be the same, which is what we've now kind of got. The thing that we don't have though, we do have a fraction, and there is no fraction here, but we're just going to divide by 2. We can divide both of these terms by 2, and that'll put it into the correct format. So 6 divided by 2 is 3, so we're going to get 3 plus or minus 3 root 10. So that tells us then that the d value we were looking for is 3, so d equals 3, and the e value is 10, so e equals 10. So So not an easy question that. You've got to pick up on quite a lot of clues as to how to go about that question. And the fact that they're working with this quadratic expression all the way through, but asking very different things about it, is kind of cool. I quite like that question, but also quite challenging. So those are the solutions for that problem.